Hello, everybody. My name is Mr. Lee, and welcome back to As Quick as Possible, a series where we discuss math and science topics as quick as possible so that you can get done with your homework as quick as possible. This is part 3 of our trigonometry series. If you are not familiar with basic trigonometry, I recommend that you check out the first 2 parts. Part 2 isn't necessary to watch for this part in particular. However, you should watch part 1 if you need to understand sine, cosine, and tangent. All right, today we will be discussing the law of sine, and this comes with the problem that I wrote up. The problem reads, a person is standing some distance away from a leaning building that makes a 75-degree angle at the ground. If the person is looking up to the roof at a 60-degree angle, and the distance from the viewer's face to the roof is 9 meters, how tall would the leaning side of the building be? How far away would the person be standing from the building? Before moving on to solving the problem, I want to state 2 things. First thing is that we are solving for 2 variables. What exactly are those variables? Well, if you look at the question, we are looking for how tall would the leaning side of the building be, and we are also looking for how far away the person is standing from the leaning building right here to here. Secondly, this is not a right triangle. This is what we call an oblique triangle. This means that there is no right angle, there is no 90-degree angle on any part of this triangle. This means that what we learned in part 1 about sine, cosine, and tangent is basically non-applicable. We need to use a different process if we want to solve for these variables. What is that process? Well, that process will be called the law of sine. What is the law of sine? The law of sine basically states sine capital A over lowercase a equals sine capital B over lowercase b equals sine C over lowercase c. Before we move on, I want to say quickly that this line over the c is only an indicator that the c is lowercase. Basically, there are 6 variables involved, some of which are solved, some of which are not, and these variables are capital A, capital B, and capital C. If the letter is capital, that means that this is an angle. If the letter is lowercase, then that means that this variable represents a side. So where are we going to start? Well, I suggest that we start plugging in for each of these values right here on this law of sine equation. So that's what we're going to do now. So we've got sine and A, we've got 60 degrees over lowercase a. We don't have that value, so we'll just put A equals sine B, which is 75 degrees. Lowercase b, we actually do have this value, so we'll go ahead and put 9 meters, equals sine C. We don't have C, so we'll just put sine C over, and then we don't have lowercase c, so we'll just put lowercase c. And since we have 2 equal signs here, we can go ahead and cut this one out since we'll come back to this one since we do actually need to solve for the distance away from the building. But as for right now, since we are solving for side A, we don't really need this part of the law of sine, so we can just deal with these 2. All right, so we're going to write this out. I'm going to go ahead and put the constants over to the left, and I'm going to go ahead and put the variable side over to the right. So we'll put sine 75 degrees over 9 meters equals sine 60 degrees over A. And if you notice from here, we can actually just do basic algebra in order to solve for this, kind of like how we did with part 1. So if we want to separate the variable, we first need to multiply by A and multiply by A on this side. That will give us A in parentheses sine 75 degrees over 9 meters equals sine 60 degrees. Now, if we want to get rid of this coefficient, technically it's a coefficient, right next to this variable, we can do further algebra and divide this whole thing over here, and then that will give us A equals sine 60 degrees over sine 75 degrees over 9 meters. And now, once you plug this all into your calculator, you will get an answer that's around 8 meters, but it's around 8.069 meters. That means that side A over here, which is the height of the building, which is one of the variables that we need to solve for the problem, is 8.069 meters. So we can go ahead and put over here for A, we got 8.069 meters. It's at this point we can go ahead and ignore this, and then we can go ahead and start with this, except we don't have C degrees yet. Well, here's the thing about triangles, if you didn't know, that each angle of the triangle is supposed to total 180 degrees. This is the same with any kind of triangle you can create whatsoever. You can't escape it. It will always, always equal a total of 180 degrees. That means we can take the two angles that we do have, 75 degrees and 60 degrees, and we can add these up to get 135 degrees. And then we can take the total that we have, 180, and we can subtract 135 to get 45 degrees. That means that C is 45 degrees. All right, now once we have that, we can do sine 75 degrees over 9 meters equals sine 45 degrees over lowercase c. And lowercase c, again, is the variable right here. That's the distance between the building and the person standing over here. So right here, we're basically going to do the same thing. We've got to separate the variable. So we multiply by lowercase c on both sides. That will give us lowercase c times sine 75 degrees over 9 meters equals sine 45 degrees. After that, we need to separate the coefficient and put it on this side right here. So we just divide all of that together. And once you plug that into your calculator, you should get somewhere around 6.5 meters. But for our purposes, we're going to put 6.588 meters right here. That means that we've solved for the variable lowercase c, 6.588 meters. We also solved for c right here, which I put, so 45 degrees. So if we look back at the problem paper right here, we now have the height of the building and we have the length that the person is standing away from the building. The distance between the building and the person being that of 6.588 meters and the height of the building being around 8.069 meters. So essentially, in a nutshell, that's how law of sine works, and I hope you guys learned something.